Hello everyone. In today's demonstration, I'm going to walk you through some of the new capabilities of ANSA, focusing on parts navigation and reporting, penetration navigation, and welds navigation. Let's start with a typical use case. As an engineer, I open the final assembly model, and my first task is to check that all parts are correctly defined, positioned, and aligned. To do that efficiently, I need tools that help me navigate through the model and filter the parts I need to review. Next, I need to generate and share a report with the team. So robust reporting features are essential, both for internal tracking and for providing feedback to the design team. One of the most critical checks is for penetrations, cases where parts intersect or overlap in ways that are not physically valid or acceptable in the final structure. Finally, I need to inspect all connections and welds between components. In the previous ANSA version, there was early version of this weld checking tool. Today we are going to see a much more complete and powerful incarnation of it, with enhanced features and greater usability. Let's start with parts navigation. After batch meshing or geometry conversion, post-processing involves critical verification steps such as checking mesh quality, confirming part names and properties, verifying thicknesses, materials, and overall meshing success. To support this, ANSA provides a contextual navigation ribbon, quick access to relevant functions, and efficient interaction tools like accept/reject actions to streamline review. I start by selecting the parts. I right-click, go to Actions, and choose Navigate Parts. Under Features, I check if any features exist. Then, in the Navigate tab, I open the Hasbrest Elements user attribute. I check each property one by one. There should be one for the pressed element, one for the mid-surface, and one with the solid description. This helps us see how well the mid-surface matches the original solid. The success rate is shown in the Details panel under the shell mid-surface, and also in the comments. If I had a lower success rate, I would go to mid-surface, inspect to find what went wrong. Then I'd apply some functions or checks to correct it. Once it is fixed, I have to check the mesh quality. I open the quality criteria flags and make any corrections using functionality embedded in part navigation ribbon, like direct edit, edit mesh, etc. If the mesh looks good and everything is okay, I approve the part. Then I also check the symmetric part to make sure it's fine. Finally, I generate a report, either interactive or automatic. Through the report functionality, a report composer is invoked and enables the easy generation of reports in PPTX format. The report composer supports text boxes, tables, spreadsheet tables, shapes, embedded objects, including images and videos, and links. Next, we move to penetration checks and navigation, an area that has seen significant improvements. This functionality is built for reliable and consistent penetration detection. Key features include part-based clustering of intersecting regions, a dedicated check draw mode for clearer visualization, and a new customizable navigation ribbon tailored specifically for penetration workflows. Both autofix and manual correction options are supported, with real-time updates triggered directly through user actions in the graphical interface. These tools help identify and resolve issues quickly, significantly improving model readiness and reducing the risk of late-stage design errors. This is the floor of the body in white of a Yaris model. On the floor, I may have some intersections. To check this, I go to Checks, penetration and select parametric. There are some available options. For example, round shell edges, which helps reduce false positives. By selecting the errors, the penetrations are highlighted on the model. I select the penetrations, right-click, and choose the option Navigate. The Navigate ribbon appears, and now I can clearly see the floor and where the penetrations occur, how many parts, how many penetration groups, etc. The penetration groups are like penetration clusters. These involve multiple interpenetrated parts that should be fixed together, since changing one could affect the others. At the top of the legend, I right-click on penetration and choose Results List, where I can see the depth in absolute value. Selecting any result also highlights it in the graphics window. This works either from the list or by clicking directly on a shell in the graphics area. There's also a Fix Visible option there. I can also do a Draw Shell as solid to better show the penetration. Then I go to Fix and choose which part will be frozen and which ones will adjust. There are guidelines in the info window as well. It's important to make decisions based on the symmetric situation too. We want to be consistent and not fix one side while introducing errors on the symmetric side. If I want to work on the symmetric side, I find it in the model browser, set it as Study Part, and work accordingly. Once everything looks good, I approve the result, and I'm done. Finally, let's take a look at welds and connection navigation. Enhanced navigation capabilities now allow for the efficient checking, validation, and correction of welds and other structural connections. Users can navigate through connections individually, leverage both existing and newly developed validation routines, and automatically detect inconsistencies or missing welds. In the previous version, we had seen a different version of this function where we navigated welds through parts and connectivity groups. Now I'm going to navigate per connection instead. I go to the Connection Manager, select Connections, and choose Navigate. I run a check connections. Once it runs, it automatically enables draw mode, so I can switch between connection view and navigate draw mode. In the legend for connections, I can click on Results List to see the errors and fix them. For example, if the heat affected zone width needs fixing, there's an auto fix for that, and I can manually adjust things like the heat affected zone quad angle using Edit Mesh. Once everything is fixed, I approve it, and I move on to the next connection. Across all these workflows, parts, penetrations, and welds, the upgraded Navigate toolset reduces manual effort, minimizes the chance of error, and saves time across the entire weld design and validation process. The result is a more robust, flexible, and user-friendly way to manage even the most complex assembly scenarios. Stay tuned for more.